Okay, we want to get started pretty soon here because we don't want to get too late in the evening. We want to be refreshed for the after party. We have Dirk coming around for round 2 from Technicolor, but he's probably going to go into more detail this time for
a bit more technical.
A bit more technical on the prototyping of their lifecycle management application. So come in and have a seat, and welcome, Dirk. Thanks.
Yay. So here I am again. Okay, prototyping a lifecycle management application, so quite a mouthful. I'll start with the who, the what, the why, the how, and the next. So first of all, by now I guess you know I'm Dirk Feytons, and that I'm a software engineer at Technicolor. I'm based in Edegem, Belgium, where I have been working for quite some years now. And my focus has always been on management plane, everything related to managing gateways, DSL gateways at first, and mostly still gateways, but we get into contact with other parts of the company that do cables, set-top boxes, and other pieces of equipment. Okay, so OpenWrt, as I mentioned in the last slide, the previous presentation, we have been using it for quite some years now, and I had the luck of being there from the early start. So I have first-hand experience in starting to work with such a software stack and getting to know it. And yes, I can confirm documentation would have been handy if it was there. It would have helped a bit in the learning curve, but okay, lifecycle management, what are we talking about here? One description or one definition could be managing the lifecycle of dynamic software modules on network devices or any devices in general. And specifically, we are talking about installing them, updating, removing them, starting, stopping, if applicable, and then see the state of these modules and possibly change some config of these modules, like a typical example, should these things auto-start after a reboot or not. The term LCM, I think it's been used in several places already. What we are here talking about more particular is the definition or the specification as given for TR69. And full details are in TR157. So for those who are not that familiar with TR69, so it's basically the standard remote management protocol used in the telco world for all the service providers to remotely manage the boxes that they have deployed in the field. And it's a standard governed by a broadband forum, so they publish the standards and all the amendments and revisions and definitions and so on in these TR reports. These are freely available on the website, so there is no paywall there. So TR69, very, very simply said, it's a protocol based on HTTP or hopefully HTTPS nowadays. Where over that HTTPS channel you exchange SOAP, XML, RPC. So, and the other side in the service provider's network is what they call an ACS server. That's roughly for that. What is now LCM in particular? The terminology as defined by TR69, it's a bit of an abstract definition that is pretty abstract, like I said. They talk about execution environments where they define it as a software platform on which software modules are installed, and you can fill it in different ways. If you have your device, you can define an execution environment as, okay, I have a Linux device, I can deploy dynamic software modules on that Linux device, so I have a Linux execution environment. Or an OSGI one, which is Java-based. You can define that as an execution environment, but whatever definition or how you fill it in, it suits the spec. Then they define something like deployment units and execution units. The U is an entity that can be deployed on an EE, so all pretty abstract definitions. But if you map these on what you know from OpenWrt, I think you can see how this would more or less fit with packages and so on. So these are the pieces. Then there is the RPCs themselves that are defined. How do you use this? So in TR69, they defined an RPC change the use state to actually manage these DUs. And then using the typical get set parameter values RPC, you can do something with what is installed on your system, see information, start, stop things, and so on. That's briefly the terminology. What did we do, or why did we create a prototype for this? Well, we see in the industry that this whole packages, software modules, dynamically installing and so on, that's something that's getting more and more popular. So in previous talk, I also mentioned this SDK that we provide. People or service providers are getting more interested. So up until now, you create this monolithical software firmware for the service providers. They spend months testing this, then it gets deployed in the field, and that's it. Maybe it gets some updates after, again, a monthly review cycle and so on. They want to get rid of that. Here are a few reasons listed. So devices get more complex. All the functionality that they have in these little devices right now, it's quite a lot. And diagnosing problems when these devices are in the field, just using TR69, gets more and more difficult. And they want to proactively detect, monitor, fix maybe even in their network without or before the end user starts calling the help desks, because that's what's costing them money. Also, these devices, they are getting more powerful. So nowadays, maybe thanks to the whole mobile phone revolution, the capabilities of these hardware things, they are getting quite far beyond maybe what is strictly needed for just the networking stuff. So there is some room now available in flash, RAM, CPU resources to run additional services on there. Security-wise, we get these more security containerization, separate these services from the core functionality, because they want to make sure that if you start running these services on these devices, that they don't impact the actual core functionality of the device. That's because then users start calling the help desk again. So they want to make sure that these services don't interfere with the rest of the system. And also, they want to move to a bit of a service-based revenue model, and becomes interesting for them, becomes viable now. Software stack consolidation, so also hinted in earlier presentations, you see that industry is getting a bit interested to consolidate on a bit of a standard foundation software stack, typically OpenWrt. So that's a good thing. So if you would implement an LCM, like described in TR69, you don't want to do that completely from scratch for each vendor that delivers these devices to you as a service provider. So you want to, if you invest in LCM, you want to do this once and have your applications that you develop, have it portable easily on the boxes of other vendors. And then last but not least, we were asked by Vodafone to develop such a prototype to actually see what would work, what would not work, how is it possible to create LCM, do LCM on OpenWrt. As we were using OpenWrt quite some years, they said, yeah, you seem to have all the expertise, and so give it a shot and see what comes out of it. How did we approach this? Well, we got some requirements outlined from Vodafone. Pretty logic, I would say, or maybe a bit new in this industry. So it had to be, this prototype had to be based on OpenWrt. Simple, no proprietary stuff, just standard stuff that can be ported on other OpenWrt-based software stacks. And also the code should be open sourceable. So make sure that when you start something, that you write something that in the future it's open sourceable. It should support the TR69 LCM model as described in the spec, so that's the primary target, because that's what the telco world uses for remote management right now. They have these ACS infrastructure deployed already, so augmented with LCM is a logical step for them, but it shouldn't be hardwired. There should be other management channels through which they would want to do some kind of LCM that isn't strictly following the TR69 model. Initially, they want to do a Linux AA, so deploy Linux applications, but it should be possible to extend this to whatever other thing AA you can define, so OGI, Android, whatever, that should fit in this in the software architecture. And last but not least, of course, keep security in mind. They want to deploy dynamically software pieces on these devices, but it should be their software pieces. Should be securely delivered to them. So we did this kind of prototype in the beginning of this year. So I think it was February, March, April, that time frame. Prototype that more or less meets these requirements, and yeah, we wanted to present this and get some feedback. How does this work, roughly, technically? So we created an LCM daemon, just a separate component. We have written it in Lua, even for now, because we are, first of all, familiar with Lua because of other development that we do within Technicolor. Because the scripting makes the software more customizable for our technical salespeople, that they don't need engineers for making little changes to the software and have to recompile it and so on. So we have made our software quite customizable using Lua. So that's what we are quite familiar with, and OpenWrt has good Lua bindings to their main core components. So we said, yeah, let's start with this prototype in Lua. It allows for easy development, easy iteration. We can write the Lua code directly on the device to see and experiment with things. So that's what we did. And then LCMD, as a good component, I would say, uses UBus to export its services to the rest of the system. So it exposes an LCM object that has a bunch of methods. They are a bit logical, I would say. They are a bit similar to what you would see in TR69, but not exactly the same. So we've tried to make it a bit generic, that they are usable for various purposes, but also you can put your TR69 stack on top of these methods and make it work. And we actually proved this by using our TR69 implementation and put this on top of this prototype and have it work fully end-to-end. We even did an interop with the Motive ACS server, and really fully end-to-end from the service provider's network, have it install a package and run it and so on over the whole TR69 part. So these methods are there. There are also 2 notifications to publish when a package changes state and to mark an operation as complete, so the system sees what is happening there. When we look at these LCM, we have this concept of packages. These packages, they have operations on them. Install and uninstall, a stop, start, and so on. So what we try to do to make it visible is, okay, a state machine of these packages. How would these look like inside of the LCM daemon? These packages get carried through all these states because of the operations being applied on them. And if we draw this out, this is more or less what we have come up with. So it's a bit, again, fairly generic. It fits the TR69 LCM model and hopefully other LCM models as well. Internally, roughly speaking, like I said, the interface itself is inspired by TR69, but it's kept fairly generic. And we have this front end that handles all the UBIS interfacing, that maintains the list of current packages that it knows about and all the metadata associated with it. And it interfaces with the actual execution environment implementations. So when all these operations are received over UBIS, we queue them and we execute them one by one, but in the background in a child process, because the main process still needs to be active for responding to other UBIS calls to check in on the progress and so on. So these are running in a child process, and we capture their output to see where they are. So, for example, things like actually downloading the package that was provided to the system with the URL. So we just, in a child process, invoke curl to do the download. Curl has all the tools and the bells and the whistles to do downloading in HTTP, HTTPS, in whatever variants that you can think of. So let's use that. And it does all the downloading for us. And then the actual AA execution environments, they will do the heavy lifting of, okay, we have this file, this package download on the file system. And it was targeted at a certain EE. Okay, we hand it over to the EE for, do something with this, unpack it, whatever you need to do to install this on the system in whatever way that you are defined to handle. So it's a plug-in architecture, like I said. So we started with a native EE as a kind of a proof that it can work. A native EE, of course, based on OPKG, because that's what we have on OpenWrt. So let's use this as a starting point. It's there. And as a kind of a proof of concept that we want to separate the stuff that you do with LCM, these LCM packages, we want to separate them from the rest of the system. With OPKG, you can simulate it a little bit by installing it in a different root directory. It's not ideal, of course, but it's just as a proof of concept you can make it work. And if you would ask for a list of these LCM packages, you can list them without getting all the rest of the system packages involved. Nothing prevents you from defining an EE implementation that represents your base firmware as well. So you could perfectly do that. So we started with this OPKG and we played around with it, but the downside of OPKG is that it's a command line tool. So we as a daemon, we want to programmatically interact with OPKG, with all these packages, but it's not a library. So it's a command line tool. You have to invoke the tool and parse the output, and you're a bit in what you can retrieve from that, because it doesn't expose all the information that we know is in there somewhere in the metadata files and so on. Also certain operations like, okay, we have downloaded a file that is an IPK. What is in that file now? Yeah, you cannot ask OPKG that without actually installing it. When it unpacks everything and stores the metadata in the database, only then can you actually see what is in the file, which is a bit annoying if you want to show information about the stuff that you downloaded before it is actually installed. So there are a bit of hurdles there for prototype. Okay, we can work around it, but it's not ideal. Also, a bit of an annoyance in OPKG is that it leans on that concept of a feed, of a repository that provides you with a whole bunch of packages, while the TR69 model really works on an individual basis. So one package is downloaded from a certain URL and doesn't really have a link with other packages directly. So it doesn't really have to come from the same source. So OPKG, like I said, we download the file ourselves and then we can ask OPKG, here's a file, install it. That works, so we could use it for our prototype. Then the next part, security-wise, so what they want to have in this LCM model, when I download something, okay, I want to make sure that that package that I downloaded from somewhere is actually okay to be installed on this device. You should at least support signing in some form. And we've seen that OPKG, there is signing support, the uSign functionality. It's there. The only thing is that it's linked again to the feed concept. So what it does, it signs the package lists instead of all the packages individually. So we've added a little bit of tweaking, added something, checksums file in the IPK with the hashes of the main files in the IPK, and then sign that using standard OpenSSL, public-private key pair, put that in there, and then when we download something, we can actually verify that it's valid. Next steps that we see for the prototype and questions and for feedback also. Currently it's really prototype quality, so robustness-wise, not ideal. It's also, it's written in Lua. It's good for prototyping. It works. We can continue, make it more robust, but maybe it would be better to rewrite it in C. Because like I said, we use the Lua bindings of the OpenWrt components, libubox and all these there, but not everything is bound to Lua, and there are certain functionalities there, the whole uloop, ustream, all that functionality. It's interesting to maybe use, but it's only currently available in C. Maybe it also for footprint would be worthwhile to rewrite in C. Persistency of state and so on. The native EE also needs certain fleshing out. OPKG is a bit of a problem. We need to do something there. Reuse something. Do we just bypass it completely and manipulate these IPKs ourselves, because they are basically just gzipped tarballs. The signing method, is that okay? Maybe we want to go security-wise beyond just unpacking something and running. We want to maybe do some containerization there. And also the whole start-stopping monitoring maybe also needs some improvements. We've seen little bits of information that ProgD is not providing us in all cases. Maybe that also needs some work there and some extensions there. So first prototype is there, feedback welcome, and then we can see how to continue. Thank you.
All right, find Dirk later if you're willing to review the code and the implementation that they've done so far. Next up, we have Sukru from Inteno. Come on up, Sukru. And you're going to talk about whole home. Is that it? No. Your talk was about quality or whole home? I can't remember which was which.
Our talk is about how to connect OpenWrt-enabled devices together and create an OpenWrt ecosystem.